Let's talk about a super cool gadget. Alright folks, welcome back. Today, we are diving into the world of electronics, but don't you worry, we're keeping it super simple and super fun. Have you ever wondered how your fancy smartphone charger can be plugged into a high-voltage wall socket without frying the delicate circuits inside your phone? Or how a giant, powerful factory machine can be controlled by a tiny, low-power computer without a catastrophic electrical mishap? The answer is a tiny, unsung hero of the electronics world, a little gadget that works like pure magic. It's called an optocoupler, and trust me, it's way cooler than it sounds. We're going to pull back the curtain and see exactly what makes this thing tick. You know me, I love building things, from squirrel obstacle courses to giant Nerf blasters. And in almost every complex project, there's a need to connect two totally different electrical systems. Think of it like trying to have a conversation between two people who don't speak the same language, and, to make it trickier, one of them is shouting while the other is whispering. You need a translator. In electronics, that's what our little friend the optocoupler does. It's a brilliant, simple, and elegant solution to a very common problem. So grab your safety glasses, just kidding, you won't need them for this, and get ready to have your mind blown by a tiny piece of plastic and silicon. We're going on an adventure into the microscopic world inside this component. It's a place where light is used to send secret messages, creating a barrier that electricity can't cross. It's kind of like sending a message in a bottle across a wide river. The message gets to the other side, but the person who sent it stays safely on their own shore. This principle, called electrical isolation, is the optocoupler's superpower. It's the reason so many of our everyday devices work safely and reliably. We're going to break down exactly how it pulls off this amazing trick, and you'll see that the science behind it is something anyone can understand. Before we get into the nuts and bolts, I just want to say how awesome it is that you're here to learn something new. Curiosity is the engine of discovery, and exploring topics like this is what leads to the next great invention. This journey is all about peeling back the layers of the world around us and understanding the clever engineering that makes it all possible. So, get ready, because by the end of this, you'll be able to explain optocouplers to your friends and sound like a total genius. Let's do this. Okay, let's get right to it. What is this mysterious optocoupler? Imagine you have two separate train tracks. One track has a huge, heavy-duty freight train thundering down it. That's our high-voltage circuit. The other track has a small, delicate passenger trolley. That's our low-voltage circuit, like the brains of a computer. Now, you need the freight train to signal the trolley, but you absolutely cannot let them touch or even share the same track, because the big train would completely demolish the little trolley. An optocoupler is the clever signaling system you'd build between them. It lets one circuit send a signal to the other without any physical electrical connection. At its core, an optocoupler is just a tiny electronic component, usually housed in a small black plastic casing with a few metal legs sticking out. It's an electronic air gap. It creates a space that no electrical current can jump across, providing what engineers call galvanic isolation. That's a fancy term that just means the input and output circuits are completely separated. They can't share electricity, they can't short-circuit each other, and a power surge on one side can't destroy the other. It's the ultimate electronic safety guard, standing watch between the big, scary, high-power stuff and the small, sensitive, low-power stuff. Think of it like this. An optocoupler is basically two separate components sealed inside one little package. The first part is a light-emitting diode, or an LED. That's right, just like the little indicator light on your TV remote or your computer. When you send electricity to this LED, it lights up. The second part is a light-sensitive sensor, like a phototransistor. This little guy is like a solar panel for a tiny ant. Its job is to detect light. When light shines on it, it wakes up and allows electricity to flow through its own separate circuit. These two parts are sitting inside the package, facing each other, with a special transparent material between them but no wires connecting them. So you have a light maker and a light detector, living together in the same tiny house, but never actually touching. They only communicate with a beam of light. This simple but ingenious setup is the entire secret. It translates an electrical signal into a light signal, and then translates that light signal back into an electrical signal on the other side. This is how the message gets across the river we talked about earlier. It's a one-way communication street, all happening at the speed of light, sealed away from the world in a tiny black chip. How cool is that? Alright, let's pull back the curtain and watch the magic happen step by step. It's actually super straightforward. Let's stick with our example of a big, powerful motor, high voltage, being controlled by a small, sensitive microcontroller, like an Arduino or a Raspberry Pi, low voltage. First, the microcontroller, our whisperer, needs to tell the motor to turn on. To do this, it sends a tiny pulse of electricity, just a few volts, to the input side of the optocoupler. This is pin 1 and pin 2 of our little chip. This pulse of electricity flows directly to the internal LED. As soon as that electricity hits the LED, it does exactly what LEDs do best. It lights up. Inside the dark, sealed package of the optocoupler, a tiny flash of light is produced. Usually this light is infrared, so we humans wouldn't be able to see it even if the package were clear. But our sensor on the other side can see it perfectly. The key here is that the signal has now been converted. It's no longer an electrical current in a wire. It's a pulse of light traveling across a microscopic gap. The electrical connection is officially broken, and our message is airborne, or at least light-borne. Now, on the other side of this internal gap, the phototransistor has been sitting in darkness, patiently waiting. A phototransistor is basically a switch that is controlled by light. When it's dark, the switch is off, and no electricity can pass through its circuit. But the moment that flash of light from the LED hits its sensor, click, the switch flips to the on position. This allows a current to flow through the output side of the optocoupler, which is connected to our big, powerful motor's control circuit. The phototransistor itself isn't powering the motor. It's just closing a gate to let the motor's own high power supply do the work. And just like that, the motor roars to life. The message was successfully delivered. The low-power microcontroller told the high-power motor to turn on, but it did so from a safe distance, using light as its messenger. When the microcontroller wants to turn the motor off, it simply stops sending the electrical pulse. The LED inside the optocoupler goes dark, the phototransistor no longer sees any light, and click. The switch flips back to off. The circuit is broken and the motor stops. It's a clean, fast, and incredibly safe way to control things, all thanks to a little light show happening inside a chip. So, why go through all this trouble with light beams and sensors? Why are optocouplers so important? The number one reason, as we've seen, is safety. They provide electrical isolation. Imagine your phone is plugged into the wall charging. A lightning strike could cause a massive power surge to come through the power lines. Without an optocoupler in your charger, that high voltage surge could travel right down the cable and instantly vaporize the delicate electronics in your phone. The optocoupler acts as a sacrificial bodyguard. The input side might get fried by the surge, but since there's no physical connection, the surge stops there, and your phone stays safe. Another huge benefit is noise reduction. High-power circuits, especially those with motors or switching power supplies, are electrically noisy. They create a lot of electrical interference and voltage fluctuations that can wreak havoc on sensitive digital circuits, like a microcontroller. This noise can cause the microcontroller to crash, misread data, or behave erratically. Think of it as trying to have a quiet conversation next to a roaring jet engine. The optocoupler completely isolates the sensitive listener from the noisy shouter, ensuring that the signals it receives are clean, crisp, and free from interference, leading to much more reliable performance. You'll find these little heroes everywhere, often without realizing it. They are critical components in switch mode power supplies, which are in your computer, your TV, and your phone charger. They are used in industrial automation to allow a central computer to safely control massive machinery on a factory floor. Medical equipment, like an EKG machine, uses them to isolate the patient from the high-voltage electronics of the machine, preventing any chance of electric shock. They are also in solid-state relays, which are modern, silent replacements for old, clunky mechanical relays that used to go clack, clack. Basically, anywhere you need to bridge the gap between two different electrical worlds, an optocoupler is likely the best tool for the job. They protect equipment from damage, they protect people from harm, and they ensure that systems work reliably by keeping the signals clean. For such a tiny, simple, and inexpensive component, the amount of responsibility it has is just massive. It's a true testament to elegant engineering, solving a huge problem with a beautifully simple idea, using a little bit of light to keep things safe. Now, making videos and writing articles like this to explore the amazing world of science and engineering is my absolute passion. It's a blast to dive into these topics, build crazy contraptions, and share what I learn with all of you. But it seriously takes a ton of time, research, and let's be honest, a whole lot of coffee to put it all together. When you take just a second to hit that like button, it does more than just make me feel good. It tells the algorithms that this is good stuff. And it helps show this content to more curious minds out there who might enjoy it. And if you really found this helpful and want to join our community of builders, thinkers, and learners, please consider subscribing and ringing that notification bell. Subscribing is like giving us a high five and saying, "Hey, keep up the great work." It ensures you won't miss out on our next adventure, whether we're building a robot that can solve a Rubik's Cube or explaining another foundational piece of technology like we did today. Every single subscriber is a vote of confidence that motivates me to keep finding new and exciting topics to break down for you. Sharing is another superpower you have. If you know someone, a student, a friend, a coworker, or a family member, who you think would get a kick out of learning how this stuff works, please share this article or video with them. The goal is to make science and engineering accessible and fun for everyone, not just for people who are already experts. By sharing, you become part of the mission. You help us reach people who might be on the verge of discovering a new passion for technology, and that is just incredibly awesome. It's how we grow this community together. Your support is the fuel that powers this engine. It allows us to tackle bigger projects, buy more components to experiment with, and occasionally blow up for science, and dedicate the time needed to create high-quality, easy-to-understand content. I read your comments, I see your likes, and it genuinely inspires me every single day. So thank you for being a part of this. Your engagement truly makes a world of difference and allows this amazing journey of discovery to continue. So there you have it. The optocoupler, demystified. It's not some mythical, complex beast, but a brilliantly simple device that acts as a translator and a bodyguard for our electronics. It uses a humble beam of light to send messages across a divide that electricity can't cross, protecting our sensitive gadgets and even ourselves. From your phone charger to giant factory robots, these tiny champions are working silently in the background, making our modern world safer and more reliable. It just goes to show that sometimes the most elegant solutions in engineering are the simplest ones. It all starts with a clever idea. I hope this has sparked a little bit of curiosity for you. The world of electronics is like a giant set of Legos. Each component, like the optocoupler, a resistor, or a capacitor, is a building block with its own unique function. Once you start to understand what each block does, you can begin to see how they fit together to create amazing things. You can start to look at the devices all around you and think, "Hey, I bet I know how that works." And that feeling of understanding is incredibly empowering. Don't ever be afraid to ask questions and take things apart, safely of course. The best way to learn is by doing, by tinkering, and by not being afraid to fail. Every engineer, every inventor, and every scientist started exactly where you are now, with curiosity. So, my challenge to you is to find something that interests you and learn one new thing about it this week. Maybe even grab a beginner's electronics kit and a few optocouplers and see if you can make an LED blink using this principle. The journey of 1,000 miles starts with a single step, or in our case, a single circuit. Thank you so much for hanging out with me today. I hope you had as much fun learning about optocouplers as I had sharing it with you. Remember, the world is full of amazing puzzles just waiting to be solved, and you have the most powerful tool in the universe to solve them: your brain. So keep it charged, stay curious, and keep on building. I'll see you in the next one.